Okay. Welcome to Epinic Web e-learning class, and today this topic is MPLS Layer 3 VPN. We will talk about the basic principle of the Layer 3 VPN and the applications, and then how to configure Layer 3 VPN. And okay, this is the time. Today is January 18th, 2017, and it is already 11:09 a.m. in Brisbane. And first, I'd like to introduce myself. My name is Jessica. I am a training officer in Epinic, and this is my contact and my specialist is the routing, switching, MPLS, IPv6, and QoS. And after this session, we will have a survey link. You can find this in the slides. And for the handouts, I will share the FTP link with you. You can download the handouts. And for this part, and some topics are from Cisco. So this is acknowledgement to Cisco systems. And in fact, in this slide, I tried to put both the configuration commands of Cisco and Huawei. Maybe in the future we will add Juniper commands to compare for the Layer 3 VPN different vendors, what are the commands to configure them. Okay, so now we will start this session. This is our agenda. First, I would like to introduce what is the MPLS VPN. There are Layer 2 and Layer 3. And in this part, we are talking about Layer 3. And then what are the advantages of Layer 3 VPN? After that, we will talk about the technologies covered in Layer 3 VPN, VRF, and RD, RT. And then these are used, the VRF, RD, RT, these are used in the control plane of the Layer 3 VPN. So how the routes? Layer 3, we know Layer 3 is the network layer, and the routing informations are included in the Layer 3 VPN. So the control plane, how the routes sent from one side to the other side, we will explain the whole process. And also the data plane. Okay, we set up the control plane, and then our target is to forward the traffic. So how to forward the traffic from one side to the other side after the control plane, the data plane, the labels, how to use the labels for forwarding. And then the last part is the configuration example. And when we are learning Layer 3 VPN, especially for some people, if this is the first time you learn Layer 3 VPN, and for the principal paths and the configuration paths, sometimes people cannot match. For example, when you are learning OSPF, and then you see OSPF and then area and the network, this prefix. But inside the principal is working on the LSA and the package something. So principal and the configurations, maybe some people cannot match when they first learn Layer 3 VPN. So we need to spend some time I would emphasize some key points for the control plane, and I would first tell you, okay, this should be configured in the configuration path, and then we need to prepare this information. So we better can combine them together, can match which parameter is used for which control path. Okay, so we will continue start the topic. Here is the MPLS VPN models. So MPLS, this technology is used very widely nowadays on top of the IP, and in fact not on top of the IP, and this is we need to run routing protocols and then using the label for the forwarding. Add the one label in front of the IP packets. So MPLS, this technology used very widely. One major reason is for the VPN. This can be used for the VPN technologies. And the VPN technologies, later we can see for data plane, there are two labels. So this is one important feature of MPLS. Label, there is listing of labels, so we can add the different multiple layers of labels in front of the packets. So based on this technology, the VPN technologies has been used. And for the VPN path, MPLS we support Layer 2 VPN and Layer 3 VPN. So layer 2 VPN, layer 2, you can see layer 2, what is layer 2? The data link layer. Data link layer is the layer 2, and in this case, the labels are added in front of the layer 2 data. Layer 2 PDU, okay, we added the label, one label and another label. This is for layer 2. For layer 3, the label is not added in front of the layer 2 header, is in front of the layer 3 header, IP header. So encapsulation, this is the difference. And for the principles, you can see layer 3 VPN, we need to, for the routers, for the, later we can see provider edge routers, they need to maintain the routing tables. But for layer 2, okay, for your service provider, you don't need to maintain my routing table. Customers, they will maintain. So the service provider network, they only act as a layer 2 network. And okay, so layer 2, we have the point-to-point layer 2 connection. And for the layer, also multi-point VPLS, like a switch, multi-point, one message, one broadcast message sent out, and all the other Cs they can receive. So this is for the layer 2, and in this part we will not talk too much about layer 2, but we will focus on layer 3. And layer 3, there is only one type for MPLS, is the BGP MPLS IP VPN. Some people call this is the BGP MPLS IP VPN, and because BGP, this protocol is very important, is very important for layer 3 VPN for the control plane, and he is used to set up the BGP neighbors between the PE routers. Later we can see what has happened in the layer 3 VPN. Okay, and for this e-learning, and if you have any questions, you can directly type in the chat box, and then I will try to answer your questions as soon as possible. Okay, so these are the models for MPLS VPN and layer 3 VPN. In fact, for me, the layer 2 and layer 3, the encapsulations are very similar. So if you understand the layer 3 VPN very well, and for layer 2 VPN, some basic parts, the main structure, you will be clear. Okay, so layer 3 VPN, these are the advantages of layer 3 VPN. And first is the scalability, and for the layer 3 VPN, the PE routers, they will set up the BGP neighbors, and easily for the CE routers, okay, they only need to set up a neighbor with PE, so they don't need to set up for each different CE routers. So this one is the scalability, and for the easier to realize the full mesh. And the security, okay, you just need to guarantee, okay, the CE, when he sends out the information, and it's sent to the right connection of the upstream PE. And in the public network, different data plane packets, they are encapsulated with 2 layers of the labels. So one is the private label, one is the public label. So for the routers in the public network, they don't know what is the information inside. Maybe for VPN A, maybe for VPN B. They just forward them to the different PE routers, the destination. But they don't know inside is which VPN. And this is about security and easy to create. So easy to create on the PE routers. So all the VPN information are on the PE routers. So we only need to maintain, mainly is the PE routers for the VPN information, and easy to create another CE, okay, create another customer interface connected to the CE, and then join the VPN instance. And flexible addressing. This is about the private IP address can be used. So for the MPLS layer 3 VPN, for different companies. Nowadays, maybe you can see in your company, you are not using the public IP address. Maybe you are using the 10 what and the 172.168 what. So different companies, maybe they are using the same private IP address. And when they connect to the same PE, for example, okay, this is company A, this is company B, and they are connecting to the same PE routers. Maybe they are from the same segments, same network segments, 10.1.1.1, and the other one is also 10.1.1.1. So on this PE, he can separate this two different CE routers. And later we can see how can we distinguish them, and better layer 3 VPN can realize this. So you can use duplicated IP address space for different companies. You can use the same space and for different companies. And the PE routers, they can distinguish them, so flexible addressing. And for quality of service for the MPLS, we can also put the QoS information in the label, tag, and okay, there are 3 bits used for the QoS information, and then we can put these 3 bits to represent maybe this is voice, maybe this service is the VIP customers, and for different information we can put the quality of service information into our labels, and then can be transmitted, can be guaranteed in our MPLS core network. And the straightforward migration, and that means our MPLS core network. We don't care under this MPLS core network is ATM or frame relay or different layer 2 protocols, and then if you want to move to MPLS, it's very easy. So this is the migration. So these are the advantages of the layer 3 VPN, and maybe I have already mentioned some of the technologies of the PE, CE, and also some VPN instance, some information, and later we will explain them one by one. So here for the layer 3 VPN topology, this is a very typical and simple topology. You can see the topology consists of the 3 types of the routers. One is the middle one, P routers, provider network, provider routers. And the most important one you can see, the provider edge router. So this is the service provider's network. And then CE, customer edge router. And you can see, you can imagine, okay, the blue color, these are the 2 branches of one company, maybe company A. Okay, I have the one branch here, and then we want to communicate with each other, and then we have our border router connected to the service, the ISP network. Okay, CE connect to PE. So this is the customer edge, and the other one, the green color, represent the other company B. Okay, so sorry. Okay, we can imagine this is B, this is A. We match to the color here. The green is company A. So for the company A, they also have 2 branches. And maybe in this example, we just list 2 companies, and each one has two branches and connected to different PE routers. And then this is the major topology. And in the middle, in our service provider network, MPLS, this is the MPLS domain. So all the routers, they need to support MPLS, support the label forwarding. We will use the label for the forwarding parts. And for our P routers, provider routers, they just in the middle for the fast forwarding of the data plane. And the PE routers, later you can see, they are very important, because you can see here, this is one customer, company A, company B. Both of them are connected to our PE routers. So PE router here, he needs to distinguish different customers, and then we can see how can he distinguish. This is the typical topology for layer 3 VPN. And so here, before we really start the principle, and this is the first important concept of the layer 3 VPN, the VRF, virtual routing and forwarding instance. So you can see for different company A and company B, when they are connected to the same PE routers, and the PE router, he needs to distinguish both of them. Maybe because I said, maybe for company A, because he has no enough the public IP address, so he is using a private IP address. For example, if he is using the same, later I think we have another topology about the IP address. So if both of them are using the same block of the IP address, and so maybe on this interface, he is the 10.11.2 and he is also the 10.11.2. Some IP addresses are the same. So how can this PE router to distinguish them? And then for PE router, he will maintain the two different routing tables for these two companies. So we call this is the VRF, the virtual routing and forwarding table. So on PE, there are two VRFs. One VRF, VRF-A, will maintain the routing information with the company A. So here I will connect it to the company A, and then maybe from the other side we will receive some information also put in this VRF-A. And for the company B, we will create the VRF-B. Okay, so inside this VRF-B, we will put the routing information from the company B and from locally and also from the remote side. So here is for the company A and the company B. On PE router, we will create this VRF information. And for yourself, for example, if you are the enterprise, you are connecting to the ISP. For yourself, you just run a normal condition, and you can see that they are running the normal situation. But in fact, the VRF configurations are on the PE routers. So CE routers, they only support IP, it's okay. You don't need to support MPLS. And so this is the normal IP routing information on these CE routers connected to PE. And maybe you will say, how can PE know? How can this PE knows? Okay, this IP address this routing information should be put into the VRF-A, and we will associate this interface. Okay, so this interface, which interface? The interface on PE, which is connected to the CE, This interface will be bind to the VRF-A, So any routing information I received from this interface, I will put this information into our VRF-A routing table, this routing table. So this interface should be bind to the VRF-A. So here we have mentioned two steps. One step, you need to define a VRF for different, how many companies you are going to connect, how many customers you are going to connect. Then you define one VRF. And so VRF-A for company A. And then second step, you need to associate. You can see associate with this VRF should associate with this interface. So this is important. And who will know which interface is used for which company? You will know because you are the engineer. You know this interface is connected to company A. So I will associate the VRF-A. Okay, so here is for the VRF and the interface under the VRF. And then continue. For this step, we will only receive the routing information from the CE, and also there are some other concepts we will introduce in the following parts. Because how can we receive some routing information sent to the other side? The whole process we will introduce, and during this part we will have the RD, RT, and the VPN label. This information will be introduced in the following parts. And for our PE routers, he has received, okay, in the previous page, PE router, he has received the routes from VPN, from company A and from company B. And how can we send these routes to the other side PE? Because this is the service provider network, and the customers are connecting with the edge router. So we want to send the routes from one edge router to the other edge router, maybe multiple hops between these edge routers. And at that moment, people consider that BGP can realize this function. Okay, so BGP is used to distribute the routing information. Here you can see VPN routes. So the company A routing information will send to the remote PE. Company B will also be sent to the remote side. BGP BGP is used to send the routes, okay, for the VPN routes to the other side. And so here, for this part, because normal BGP cannot realize this function, so we have extended the BGP to be MPBGP, the multi-protocol BGP. Some other address families are used to send the routes. Later, you can see why normal BGP cannot send the routes. And then RD, RT, and VPN label. This information will be covered when we are using the BGP updates to send the information. Okay, now we will start the introduction of the RD and RT, the functions and how to use them. RD, route distinguisher. So the name is very clear. You can see route distinguisher, to distinguish the routes. Which route? For the routes from the VPN. I said maybe company A and company B, they are using the same IP address space. So how can, when PE routers, okay, he put them into the different VRF, but when he send out, how can he distinguish these two routes? And because all these IPv4 parts, they are the same, 10.1110, 10.1110. How can he distinguish in the BGP updates? So we will change the routes. We will change the routes to be VPN v4 address. So before is IPv4. Okay, IPv4 they are the same. If they are the same, okay, these are the different types. And if for the IPv4, all of them are the 10.1.1.1. How can we distinguish them? We will put different RD. We will put different RD in front of this IPv4. So this one, we call it, this is whole length has been changed. You can see with the 8 bytes and the 4 bytes, we call this together 12 bytes is the VPN v4 address. So we will put different RD for different VPN instance, for different VRF, and then we can distinguish them. Okay, so this is the RD. So please remember, RD is used to distinguish the routes. And the length is the 8 bytes. So maybe you'll say, RD, what is the format? So his format can be the 100 to 1. So it's the AS number and maybe to some other code. And then maybe one IPv4 address and colon 1 code. Then it's up to you. You can use in your AS number and then based on different PE and different VPN information and then put different RD. You need to design just locally on one PE, different VRF. They are using different RD. Okay, so this is the RD information, and we will have the example in the next page. So first, you need to know the formats. So for different companies, they are using different formats. Some companies they are using the AS number. Some companies may be using the router ID, the IPv4 address, and to some with the code. And then this is the RD you need to configure. Okay, you need to design and configure. You want to configure layer 3 VPN. Okay, so RD is used like this. We mentioned, okay, for CE, for VPN A and VPN B, they are using the same block of the IP address, private IP address, and connected to our PE. And on PE, he has configured RD for VRF A is 100 to 1, and VRF B RD is 200 to 1. You need to configure different for different companies. And then MPBGP can be used to advertise the routes. So normal BGP here is only used to advertise the IPv4 routes. But here we need to distinguish these two. You can see they are the same. We need to distinguish them, so we put an RD in front of that. And then normal BGP doesn't understand what is the VPN v4 routes. How can they understand MPBGP, multi-protocol, the different address family? So VPN v4 address family can support. This one can announce the prefix to the other side. So here is the VPN v4 prefix 100 to 1 to 10.1.1.0, 200 to 1 to 10.1.1.0. And then you can see these routes are different. So BGP, he can distinguish, oh, these are the different routes. One is 100 to 110.110. They are different VPN v4 routes. So VPN v4 is here. So some people maybe when they first learn this one, they will be confused. So what is VPN v4? VPN v4, initially the concept is about the routes. The routes format is like this: RD plus the IPv4 address. So RD is designed by you. So in fact, you are involved in the VPN v4 configuration. So here, this is the VPN v4, and for the address family, later you can see we have the address family of VPN v4 is used to set up from one PE to the other PE, send out the rules. Okay, so here the routes has been converted to a VPN v4 prefix. We know the RD, and RD, I just emphasize RD locally. This meaning is only locally. So for the locally different company, they are using different RD to distinguish them. And another concept, RT. This concept is used to make the topology more flexible. So we have the intranet, extranet. So intranet, all nodes can access to each other. Extranet, maybe he can access to some of our intranets. The RT can be used to control which routes will be received by the remote side, RT. And the RD, for one VRF, only one RD. But RT is different. First, there are two types of RT: export RT and import RT. And RT, this one is a BGP extended community. This is in the attribute. This is the attribute. Okay, so RT is the attribute. For example, you can imagine for BGP attributes, we have the next hop, local preference, MED, all these are attributes. RT is another attribute. In RT, we have the two types. One is export, one is import. Where to use them, I will explain in the following pages. And then the format, RT, the format is the same as RD. Okay, so maybe the AS number to some code and maybe the IPv4 address and to some code you can design by yourself. And the RT, this design will up to your requirement of your topology. And how can we use this? Two types, one is export, one is import. And for export and import, you can configure multiple RT. For example, export RT, you can configure 100 to 1 and also 200 to 1, and import, maybe you only want to configure 100 to 1. So you can configure multiple RT for both the export RT or import RT. Is up to you. This is very different. So RT and RD, we need to distinguish them. And RT, when we send out one route, you can see here PE1, he will send out the route. Okay, this is the VPN v4 route. How can we know this is VPN v4? You can see this is RD added in front of our IPv4 address. This is the VPN v4 in front of IPv4. So RT will be included as the attributes in the BGP update message. And before we go to the distribution, and you can see for different VRF, we have configured some import RT and export RT. So here on the VRF-A, we have the import RT is 100 to 1, 100 to 1 for export. And the VRF-B, we have configured 200 to 1, 300. So different numbers are added here. And for P2 VRF-A, we have configured 100 to 1, 400 to 500. So the import and export RT numbers are listed here. The numbers are listed in these two tables. And here, first we need to know where to use different numbers, because you have import, you have export, how to use them. The VRF-A, for example, if we send out one route, okay, here is using the VPN-B. We send out one route 10.1.1.0. We send out the route we need to add some RT into our BGP message. So which RT will be added? You have so many RT. You can see VFB, we have import, export. Here, export RT will be added here. So this is the export. So when P1, he send out some routes to the other side, to the remote side, he will put the export RT for this VFB export RT 200 to 1, 300 to 1 into this BGP update. And then when this BGP update received by the PE2, PE2, he needs to decide in which VRF I need to put this route. In which VRF? Who will decide? RT. RT will be used to decide which VRF I will put this route. How can we decide? We need to compare the value. Then compare with what? Import. So in fact here, both VRF-A and VRF-B, the PE2, he will compare with your 200 to 1, 300 to 1. These two values compared with the both VRF-A import RT, VRF-B import RT. You can see, if we first compare with VRF-A, I have 200 to 1, 300 to 1. And then compare with the import, 100, 400, 300, not matched. So cannot be put into VRF-A. And then compare with VRF-B, 200 to 1, 300 to 1. And here, VRF-B, 200 to 1. So another question. Maybe you will say, should they match both of them or only one is enough? One is enough. Okay, so 200 to 1 is matched. And then we can put this route into VRF-B. So maybe in this one, you have 200 to 1, 200 to 1, and this route can also be put into the VRF-B. So the RT is used to control whether this route will be put into the right VRF. Okay, so this is the route advertisement by using RT. So any questions here for the RT function? Because for some new learners, when they learn the RT, okay, yes. You can type the questions in the chat. So for your part, for our engineers, normally you only need to configure the right RD and RT configured on this information. Yeah, on the remote router you mentioned. It's important to note the import and export RT. Yes, when you configure on the routers, you need to configure import RT is which value, export RT is which value, and then the routers, they will compare. Yes, so in fact, because the communication is bidirectional, so both sides you need to configure the import export RT clearly. Okay. And you can see RT, there are many possibilities. You can see maybe someone has this one, multiple RT and them. So why do we design to be so flexible? Because we have different requirements for the VPN topologies. You can see here, these are the two very popular VPN topologies. One is the full mesh, one is half spoke. So full mesh, what does this mean? That means, okay, I have the branch A, branch B, branch C, branch D for the same company. We have different sites, and we just want them to communicate with each other. Then that's it. Okay, so when we want to communicate with each other, just make sure his export can be accepted by the other import. So the requirement is very simple. Full mesh. Full mesh, then you can see for each site, we are configuring the same import and export RT. And you can see, you can imagine, for example, for these two sides as the example, if we want to communicate, okay, in the middle, this is the middle is the MPLS paths, and I did draw them, okay, and you can see for the site, if my export is 101, I send out the route, and for this site, whether he will receive or not, my export is 100 to 10. And then for this site, his import is 100 to 10. That means, okay, this site will accept my routes. And then for this site, his import is also 100 to 10. He will also accept my routes. And then this site will also accept my routes. So my routes will be sent to all the other sites. And then same, from the routes from different sites, the export are all 100 to 10. Also can be received. I also can accept all these routes. For example, when he sends the routes to me, and then 100 to 10 is his export, I will compare his export 100 to 10, compare with my import, also matched, and then I will put the routes into my VIF routing table. So then you can see all my routes are learned by the other sites. And for the other sites, I have learned all the routes. And the same for all the other three sites. Then they can share all the routing information, and then they can talk to each other. So this is for the full mesh. And it's easy to realize. Just configure the same import RT and export RT for every site. And that is the simple one, full mesh. And the other one is the hub-spoke. Hub-spoke is also a very popular topology. What is hub-spoke? So we have the hub size and the spoke size. That means, okay, the hub site is like the headquarter, and then there are some branches. But for the headquarter, he required the branches, they cannot talk to each other. They cannot. So here we don't have the connection. You can see we don't have the connection between them. The spoke size, they can only communicate with the hub site. Okay, spoke size only can communicate with the hub size. And for the how to realize this by using RT, you can see the hub site, his RT, his export RT is 100 to 12, and then the spoke size, the import is 100 to 12. Okay, so my announcement can be accepted by the spoke site. Also can be accepted by this one and also by this one. So the spoke size can accept all these routes. And for the spoke size, if they send out a route, his export is 100 to 11. 100 to 11 is this route can be received by the other spoke size. You can see 100 to 11 is export. But what is his import? 100 to 12, not matched. So this spoke site, he cannot accept this route. And also for this one, his import is 100 to 12. You are the 111. I cannot accept. And then, okay, but for the hub site, whether he can accept the routes from spoke site, 111, and then his import is 100 to 11. So they are matched. Okay, they are matched. And then spoke size routes can be received by the hub size. And through this way, you can see the hub size can get all the routes from the spoke size. But the spoke size, they cannot talk to each other directly. Okay, so this is the hub and spoke. So any traffic, okay, even for example, the spoke size, if they want to talk to the other spoke size, the traffic will come to the hub size. Okay, so all the traffic will come to hub size and then send it to the spoke size. So for the headquarter, they can control all the traffic. They can control all the traffic, monitor all the traffic, even between the different spoke size. So this is for the hub spoke. And the RT, you can see the hub size import is the export of the spoke size. and his export is the import of the spoke size. Okay, so any questions you can type in the chat box. So you can see here is the two very common example of using RT to realize different VPN topologies. One is full mesh, one is hub spoke. These two are used very common. So we can here in the hub spoke scenario, how can we make the spoke size communicate with each other through hub size? So here, when the hub size he has received the routes, you can using the default routes, or maybe using for the hub and spoke, this connection for different vendors, they have different solutions. The most common one is using the two interfaces from the CE to PE, from the hub CE to hub PE, using two interfaces. One is for the in routes, one is for the out routes. So you can see the spoke side, they have sent the routes to hub side, and then from the hub side, he can also send out the routes to the spoke size, send out the other. For example, his route is 10110, and then the hub size also can advertise this route to spoke size. So for spoke size, if he wants to talk to the other side, okay, he will send the traffic to the hub size, and then can communicate between them. And also you can use in a default route. For example, and then spoke size, and for any destination, if he doesn't know, he will send it to the default route and send to hub size. But hub size, he knows, I know everywhere of my internet. Okay, so he will forward it to the other spoke size. So this is using the default route can be used. So these are the two solutions normally used for the hub and spoke scenario. Yeah. And for different vendors, they are using different solutions. As I know, Juniper and Cisco, they can both support the two interfaces from CE to hub PE, two interfaces or maybe one interface. And for Huawei, normally they are using the two interfaces for the hub and spoke, the hub CE to hub PE, because they also want this hub site. You need to consider the hub site is for the CE path, and for the hub PE, they should have some configuration. We want the traffic also come to PE and come to CE. Okay, so here you mentioned that there is some simple solution. Okay, I can see you want to use the RT to control. You want to use another. But in this case, for example, hub size, I think in this case they are the full mesh. Do you think so? Because all of them, they are using the same import and export RT for both the hub site and spoke size. They are the same. Yes. Yeah, this is the full mesh. This is not the hub and spoke. Okay. Okay, so here this is the two common full mesh or hub spoke, the VPN topologies, and also you can make the combination of the RT more complicated, and then we can realize different scenarios. For example, for the extranet, maybe some sites Maybe some sites can only visit one or two of your sites, and then the other paths cannot visit, and then you can realize by using the RT control. So here is the RT, and at this step, I want you to understand how RT is worked, and then this will easier for you to configure to design RT. Where to use the import RT is used for accepting the routes. Export RT is used to send out the routes. Okay, so here for then another one, label. So we have mentioned, okay, this is MPLS network. We are using the labels for forwarding. And for MPBGP, he had the RD, okay, extended the route to be VPN v4 route. And the other way, he has extended the RT, okay, extended the community. This is the one community attribute added in our updates. And another extension for this for the BGP protocol, label. Label will be distributed in the BGP update. So before, maybe you can say, oh, BGP is used to distribute the routes, not only routes, but here you can see a label is distributed. So MPBGP, they would not only send the routes, I would also give you a label. So for PE2, he will receive one private label. So private label is generated here in the MPIBGP, in MPBGP. So you can see from here, the PE1, okay, he has received the route 200, the 10110, okay, first operation, added RD, 201 added here, okay, received from this side. And then our export RT has been put into the update, export RT. And then what information? Local label. BGP, okay, will generate a label for this, for the VPN for this route, And also put the next hop is the PE1. We know BGP we have the next hop. Next hop will be changed to be the PE1. PE1. Normally for the BGP neighbors, the loopback address, okay, they are using the loopback address to set up neighbors. So next hop is his loopback address, and send it to the other side, PE2. Okay, and for PE2, when he received this label, this update, he will add this route into VRFB because we compared the route, the RT information. Okay, export is here, and then he compared, and then he put into the VRFB this route and marked the out label is 100. Out label is 100. So if any traffic wants to go to this destination, I will add the label 100. Add the label 100. And the next hop is PE1. And how to go to PE1? We will use the LDP, LSP. Okay, another label will be used. So at this step, in this page, I hope you understand the MPBGP will generate a label for this route and send it to the other side. Okay, so the label will be sent to the neighbor. And so the routes has been sent to the other side. So the private routing information has been implemented. The control plane, the major path has been realized, and then the route will be sent to the VPN-B from this interface. And here we will have a walkthrough of the control plane. This is mainly about the private the routes and also the private label. And later we will explain the public label. This is also an important part of the control plane. So here, what is the whole process? You can see from this one, step 1, you can see we have one route, 10110/24, and then the next hop is CE1 is here when I send it to the PE1. So using which protocol from CE1 to PE1 is up to you. You can, for different vendors, they can support all the routes. You can use a static route. You can use BGP, you can use OSPF, you can use ISS, you can use ERGRP. So just set up a neighbor from CE1 to PE1. We can send the route to PE1. And then from your PE1 to PE2, how does this route send to the PE2? So here is the updates. You can see receive the updates via different protocols, and then on PE1 he will do some operations. I have already explained in the last part. You can see we will put the RD information. RD will be added, and then change the next hop, and the outgoing RT, the export RT will be added in the update, and also assign a label, and then send out to the other side via the MPBGP protocol. Okay, so these are the operations done on this PE1. He will send out to the other side. So remember, RD is used to make this route to be the VPN V4 route. And then next hop is added, PE1. Okay, he will change the next hop to be himself. And RT, export RT, and the label. This is a private label. This label is generated by BGP protocol, and then will be received by PE2. PE2, he will check the RT. Okay, your export RT. I will compare with the import RT with my different VRF. So different VRF, they will compare. Okay, which is the matched, and then put this route into my VRF, and then from PE2 send to CE2 via the normal protocols. So from this interface, so send to remote side, and then we can realize the control plane. The control plane has been sent. The route has been received by the other side, and then so different branches of one company, they can get the routes of the other side and then communicate with each other. So this is for the private label and for the private routes. We call these are the private routes, and this is the public path. This is our public path. And then, so I mentioned for the label, for the tunnel label, in the core path, we need to run LDP, Label Distribution Protocol. Why? You can see from this part, you can see, okay, if this is the control plane, and for the traffic will go from this side, traffic can go from here. But when the traffic come here, okay, I have a label, I can use a label. Maybe some people, I can use a label, okay, 100. But if you are using 100, can you reach this one, PE1? Your next hop is some P routers, but your next hop should be PE2. How can you go to the PE2? Your neighboring router is not a PE2. So we need to make this packet go to the go to PE1. Here we add a label 100, and the next hop should be the PE1. So how can we go to the PE1? If you want to go to PE1, and then we need a label for forwarding because you already encapsulated in a label. So in the public path, we need to have a label to help you, have a LSP to help you to forward this private packet, okay, with the 100 label to reach the PE1. So how can we realize this? LDP. In the MPLS core path, we will run LDP to make the PE routers, they can reach each other via LDP, LSP. Okay, so we will run LDP. These are the neighboring direct neighbors. So here, for the PE2, he will generate the LSP. You can see, if I want to go to 1111 is PE1, and then the outgoing interface is Ethernet 0/1, and the out label is 25. Okay, P2, well, the local label is the 25, and the out label is 50. And then P1 is the penultimate hop. And then he will pop out the label and then reach P1. So this is the tunnel label set up by LDP. I will not explain LDP detailed here, and then you just need to configure LDP. Some company, they are using RSVPTE, so the out label can be LDP or RSVPTE This is up to you. Okay, so this is the tunnel label, and so till now you can see for the forwarding path we have the private label here and the tunnel label here generated by LDP, and then so our control plane is totally ready. So control plane are related to 3 paths, 3 elements. One is the private route. This is a layer 3 VPN, so we need to send the route from one branch to the other branch. Routing path should be ready, private routes. And the second, private label from PE to another PE. The BGP, MPBGP will generate a label, private label. And then a public label. Here is also called the tunnel label. Tunnel label is distributed by LDP. Okay, so we need to configure LDP. Okay, these are 3 elements will be used for the forwarding path. So here, when we want to forward the packets, we can see the destination is here, 10110. 10110 is here. So the IP packet 101. So first set 2, he should know there is a route 10111. Yes, because we send the routes here. So I want to go to 10111. Okay, CE2 said, oh, next hop is PE2. Okay, send the packet to PE2. This is a normal IP packet. Okay, IP packet. My customer size, we don't know MPLS. We are running the normal IP network. 10111. Okay, send to PE1, PE2. PE2, he will search. He can support MPLS, so he will first search a label forwarding table, and then add the private label 100, and then public label 100. But next hop is PE1. But how to go to PE1? We need to use the LDP LSP. So the 25, another layer of label is used. We will add this one, and then send it to PE2. PE2 will send it to PE1. Just swap the out layer of label. Okay, 25 to 50. And the P1 router is the penultimate hop. It will pop out 50, and then send to PE1. PE1, he will check incoming label is 100. I know this one because I send the other side 100 used for this destination. Then he will pop out this label and find under this interface, send it to CE1. So this is the data plane. Data plane, we can see PE2 here. He will add 2 layers of labels. And then P1 is penultimate hop. And PE1 will pop out a label and send out to the IP packet. So this is the data plane for our layer 3 VPN. And you can see the control plane is from this way, data plane is from the other way. This one, the directions are different. You should be clear with this one. So this is the principle of the layer 3 VPN. And here I have put the 2 scenarios for layer 3 VPN application. This one is a very common one I mentioned before for different companies. Different companies with different branches, and they want to communicate with each other, but they are in different cities. Okay, they can connect to the ISP network, and then they want to simulate they are in the same network. Okay, so they will connect it to the VRF on the different PEs. So MPLS, the ISP network will act as the public network for different VPN are running. They are sharing the same public network. This is a very common one. So okay, the branches talk with HQ, and the different branches, they can communicate with each other. This is one scenario. And another scenario, this one is more often for the ISP network. Inside the ISP for the telecommunication network. This is called the IP carrier network, because nowadays we have for the core network path, we need to carry the signaling information, voice information, media, and network management information and we are using an IP network to carry this information. How to separate these different informations? So then, for the telecommunication networks, they will have some private IP network to carry the communication between for our signaling. For example, soft switch will generate the signaling, and how can this soft switch communicate with the other soft switch? And we are using the IP because nowadays we know everything all on IP, so we can build up the IP network. And the MPLS network can be used because we want to separate different services. Signal is here, media from the media gateway, and also the SGSM, GGSM for the different voice or media information. So we can create a VPN for them, and for the communication, separate them. And at the same time, quality of service can be implemented. You can see, okay, for signaling, we can configure some quality of service, and for the media parts, maybe different quality of service requirements, maybe higher bandwidth, maybe for the soft switch, the higher importance. So different services are carried in a separate VPN. This is another scenario for the IP carrier network for the layer 3 VPN is used. And how to configure layer 3 VPN? Here, this is the example on the Cisco routers. On Cisco router, I have put a very simple example here. So you can see in the middle, this is our public network, P routers in the middle, and then two CE routers, and they want to communicate with each other. Our final purpose is that CE1 can ping CE2, and they can learn the routes of each other. Okay, and now we can see. First, you need to configure the IP addresses. IP address is configured by yourself. Okay, basic configuration IP address. IGP for the core paths, MPLS network, you need to make the P1, P1, P2, PD, P2. They can communicate with each other. OSPF, ISS, and EIGRP, up to you. Okay, and then we will start the configuration. So for the MPLS and the LDP configuration, first you need to enable MPLS and the LDP. And okay, for all the PE and P routers, LDP is used for the public label. So for Cisco routers, by default, you need to enable the IPCEF. If you want to run MPLS, you need to enable IPCEF. And this is the route ID. Route ID for the LDP, you first need to configure the route ID. Here we are using the rollback 0. And then in the interface, you need to enable MPLS forwarding and also the LDP. LDP will be enabled, and then he will set up a neighbor with the other router. So you need to enable. One thing I need to tell you here, for the PE to CE, this interface, you don't need to run MPLS because we are running IP here. So you don't need to run MPLS or LDP in this interface. Okay, from PE to CE, this interface, but inside you need to run the MPLS and LDP. Okay, and then you need to order PE and P routers. And the second one is the VRF. So here for the VRF instance, you can see company A, maybe the name is VRF definition, and you can configure company A, company B. You can define the name. And RD, we can see this is RD for different VRF and different RD, 100 to 1. And RT, we can configure export and import. Here I configure both of them are the same, 100 to 10. And then in the address family, IPv4. So here I just put the address family IPv4. This is the used for the IPv4 neighbors. And then put the interface PE to C. This interface, put it in the VRF for the VPN A. So okay, this interface is bind under the VRF. Which interface? I will show you. this interface is bind under the VIF. This interface is also bind under the VIF. So this configuration is only on PE and yes, these are only on PE routers. So you can see for layer 3 VPN and also for layer 2 VPN similar, the most configurations are on the PE routers. Okay, so we put the interface in the VIF, and after that configure the IP address 10.1.1.1. Okay, and then for BGP, we need to set up an MP BGP neighbors. So how to set up MP BGP neighbors? On router BGP 100 and neighbor 4444, and then address family VPN v4. Okay, MP BGP address family VPN v4 is used for the MP BGP neighbors. MP BGP neighbors, and then neighbor 4444, and send the community both. For Cisco routers, we need to send the community both, because by default he will not send the community. Maybe you say, what is community? RT. RT is a community attribute. So if you don't configure this one, RT information will not be sent out. Okay, so add this command. Don't forget this one. And so MPBGP label will be set up from PE to CE, and from PE to PEs. And here from PE to CE, we are using BGP. And then for the neighbor, we are using, go to the address family VIF VPN A. So for PE to CE, the neighbor is enabled in the VIF. And on CE side is a normal BGP neighbors. So okay, we just go to the IPv4 address family and neighbor activate, and then advertise the network. CE will announce his own prefix to the PE, and PE send it to the other side. Okay, so this is the VIF. And normally for the new learners, which part they will confuse is here. For the PE to CE in the VIF address family, and for the PE to PE were VPN v4 address family. So you need to distinguish. This is for the PE. Okay, this is for the PE to PE. Why? Because we are using the MP BGP neighbor. Okay, so VPN v4 routes are sent here. That's why we are in the VPN v4 address family. And for the next one is also on PE. Where are we? We are in the IPv4 VRF VPN A, and this one is for the PE to CE. And all this is here is the eBGP. Okay, so PE to CE we are in the VRF address family. Okay, so this part you need to distinguish, and you can see RT we have configured inside the VRF. Now the configuration is done. Okay, and how to check, and then we can check the BGP neighbors. For the on the PE1, you can go to the BGP VPN v4, and then you can see what are the routes. What are the routes you have learned in the next hop. You can see on PE1 he has already learned the 200.110, and the path is from 65002 from the other side, sent to this PE1 and received from PE2. PE2 is 4444, and then you can see this BGP route is not the IPv4, is in VPN v4 unicast for this VRF. And also the reachability, the first one you can show, okay, CE routers whether they can ping each other. This is the basic parts we can check. And these are the checking. And but for the troubleshooting, there are some steps you should know. You need to if, for example, if you have seen, okay, the VPN A cannot communicate with the other side. Normally, first you need to check route has not been received. Then you can see whether he has sent to the P2, and if P2 has received, whether he has sent to P1, and if P1 received, whether he has sent to C1. So you need to check step by step. And also the LDP, the public labels, LSP, you also need to check. So then these are for the troubleshooting. You need to check after you know the principle, and then you know the route should be sent from the P2 to P1, and then you need to check the VPN v4 label is set up or not. So these are important. And here is another configuration example. The example is the same, but he is using the Huawei commands. And the Huawei commands are very similar to Cisco commands. So if you are familiar with Cisco commands, it's easy for you to learn Huawei commands and vice versa. And then here, for the Huawei commands, first same IP addresses configuration on all these routers, and the IGP configuration, and okay, same different OSPF ISS you can configure on the core path. And then steps are the same. Configure MPLS and LDP. And here you can see on P1 I configure the LSR ID, and then MPLS enabled globally on one router, and the MPLS LDP globally enabled on the router. And okay, go to interface. I enable MPLS and LDP. This is the configuration. So, and then create the VRF. So in Cisco routers, he call it VRF. On Huawei routers, he call it the VPN instance. Name is VPN A. And then we go to IPv4 address family, and then RD. He put the route distinguisher same. And VPN target. VPN target is the RT. So in Cisco call it the RT, and Huawei call this is the VPN target. 100 to 10, both. Both means both export and import are the same. You can also configure export or import, so different syntax can be used. So create the VPN instance, and then we will bind the interface from P to CE. Enter this interface, enter this VPN instance. IP binding, put into this instance. And you can see, after you bind one interface into one VPN instance, all the IPv4 and IPv6 configurations are removed. So before this command, you configured any IP address on this interface will be deleted. And then we configure the IP address. After your binding, and then configure the IP address, and then the mask. Okay, and after we create a VRF, then bind the interface, same. We will configure the VPN v4 neighbors. You can see for Huawei BGP 100 peer 4444 is setting up a neighbor, BGP MP BGP neighbor, and enter the IPv4 VPN v4. So here also go to address family peer 4444 enable. So here connect interface loopback 0 is the same as Cisco update source loopback 0. Okay, and for the eBGP neighbors, P to C, we are using eBGP neighbors, and I mentioned a different address family. So you can see BGP 100 IPv4 family VPN instance. So go to this VPN instance. This is the VPN instance address family, and then set up a neighbor from P to CE, P to CE. And then for the on the CE, we will set up the normal eBGP neighbors here, and then announce one prefix, network 100.110. So we configured we have configured the static route. Okay, and then send it to the other side. So these are the configuration, and then next we can check the commands. Check the results are here. You can see. You check the on CE. You can here is on P. We will check the VPN v4 routing table, and then what is the next hop. And this is the routing table. Okay, 201 has also learned from the 2224444. You can see this routing table is very similar to the Cisco one, and also the detailed routes. Detailed routes you can see for 201.1.0 label. You can see I mentioned for BGP we will distribute a label. The label information is here. Label this is for the private label distributed by BGP, and the next hop is 4444 for next hop. Okay, and then for the CE, he has learned this route via where eBGP, and for the this is the same as AD in Cisco administration. The distance here is the preference, protocol preference. Okay, so we have learned the routes. So that's all for the layer 3 VPN. Any questions here? Okay, so if no questions, and then you can use our handouts to have a review, and if necessary. Okay, if there is one question, you can raise your question. And now I would share the FTP link with you. You can download our materials, our handouts. Okay. So here is the handouts you can download. Oh, okay. Here is the FTP link. You can download all the 3 materials for today's session. And yeah, and if you have any other questions, you can also send an email to me or to the training. And here for the member service part, if you have any questions, you can also ask our help desk for managing your IP addresses and autonomous numbers, these resources. When can you share the video on YouTube? And on YouTube, now we already have one layer 3 VPN already shared, and this one I'm not sure when shall we share, because we will how to say, connect some of them and then compare and upload one, and I cannot guarantee this one will be uploaded. Okay, so on the YouTube we already have one. And you can search APNIC training on YouTube. Okay, so thank you. That's it for this session.